have notes about this. When we classify triangles, and that's what we're talking about today, the classification, we can either classify them by their sides or by their angles. And the first one we're going to do is by their sides. By sides. And when I give you a quiz, I will say classify this by its sides. What are your three choices when you have triangles? I don't want the names of them. I want your three choices. When you draw a triangle, either you can have all the sides are equal, by the way, and the way that we show that in math, generally speaking, is they put these little things here. If you see a tick mark in all three of them, that means the book or whoever's doing it is trying to tell you that all three sides are equal. Or you could have just two sides equal, like this, or you could have no sides equal, like that one. Although, yeah, that's fine stuff. Okay, so you've got three equal sides, two equal sides, or you have no equal sides. Isn't that just about the most exciting thing that could happen to you? Alright, first one. Three equal sides is called, Ashley?
Equilateral.
Equilateral. We're not done yet. Now, equilateral triangles have, because they're all three equal, Kyle, they have some special characteristics besides having three equal sides. Colton, shoot. Give me something that you know that's true about an equilateral triangle besides having three equal sides. Not only are they acute angles, as Colton says, which is true, but they are all equal acute angles. And knowing that one small fact, that there are 180 degrees in every triangle, guess what each angle has to be? And it's not 90, if you were wondering. 180 divided by 3 angles, Gabe, is, yes, has 3 60-degree angles. Okay, and that means no matter how big the equilateral triangle you draw, it's going, my equilateral triangle could be this big. If it's equilateral, every angle on that triangle is going to be 60 degrees. It doesn't matter the size. If it's got 3 equal sides, it has 3 60-degree angles. And they are all equal. 3 equal sides, 3 equal angles. Whew, that's good. 2 equal sides. Gabby Barron's 2 equal-sided triangle is a... That is not quite right. What's my next choice? Makulicek? Isosceles. Now, there's also a certain fact about isosceles triangles. Besides having 2 equal sides, they also have, now maybe this will be a little hint, a 3 equal side triangle had 3 equal angles. A 2 equal side triangle has, Alex? Yeah. And that would be the 2 sides, the 2 angles opposite the equal sides are equal. And there's not, they could be any degree. You can't say they're 60 degrees or 80 degrees or 100 degrees. They couldn't be 100 degrees though. Okay? The 2 angles opposite the equal sides are equal. Okay? And the beauty of that, children, would be this. If I have an isosceles triangle, and I know that these two sides are equal, if I know that this angle here is 20 degrees, I automatically know what the other two angles are as well. And it's not 20 degrees. I know that this is 20 degrees, but I know these two angles are the two that are equal. How in the world would you figure out what or how many degrees those are? Kyle?
20 divided by 160.
20, I'm not sure where 160 came
Divided by
from.
160.
What? Alright, Kyle's got it. We know that there's 180 total degrees in an angle. 20 of them are right there, so you're left with 160 degrees. And both of those have to be equal, so you have to cut it exactly in half, and each one would have to be 80 degrees. Okay. So you have to be a little Sherlock Holmes. And then the no equal side one shouldn't be too bad for this. No equal sides, Lauren?
Scaling.
Yes, scaling. And if something is scaling, none of the angles will be equal, nor will any of the sides be equal. Just the way it is. Just the way it is. Good for you. Alright, so that's classifying them based on their angles. I'm sorry, by the sides. That leaves us with classifying by their angles. And we've got three choices by their angles. One of them is if the triangle happens to have a right angle in it. One of them is if the triangle happens to have a really big angle in it. And the other one is if the triangle happens to have smaller angles in it. And I know this will be tough for you. By their angles here, what do you suppose this triangle's technical name is? Mackenzie? You are correct. It is a right triangle because it has one right angle. Couldn't have more than one right angle, ever. This one here has a big angle in it, and that one would be called, Nicole? Very good, an obtuse triangle. And the third one has all small angles in it. It is, Taylor?
Acute triangle.
Yeah, it's an acute triangle. Now please note that an acute triangle has to have three acute angles in it. Because this one actually has two acute angles in it. This one has two acute angles in it. Okay, an acute triangle has to have all three acute angles. Oh, wait. What else? Oh, good. I knew this would take a while. Alright, under triangles then, we also have to talk about how to find the area of a triangle. Anybody want to throw at me the formula for the unfair area of one fair triangle? Zach Rice was close. What do you think, Zach? Got it for me? Oh, the maps test. Alex?
Square times radius times radius. No.
That would be the area of a circle.
Okay.
That's good to know that one. Ashley?
Length times width, height.
Okay. Well, actually, we have to call it not length times width, but base times height. And there's a good reason for that. Abbreviated, we write it like this: area equals 1/2 BH. And we go with the base and the height. Why? Does anybody know why we call it base times height and not length times width? In math, anytime you're talking about the height of an object, anytime, Josh, you talk about the height of an object, what is that?
The up.
It is the up, but there's a special thing that the up thing does there. Ava?
how tall it is?
Yes, but there's a special thing about how tall it is. Anytime you see the words base and height in math together, Lauren, anytime you see base and height and math together, Morgan, not always. There's a special thing there. One more shot here, Gabe. I'm going to give you a chance. Well, base and the height, these two things must form a right angle. The only way for you to call something the base and the height is they have to be two things that form a right angle. Okay? In other words, this. If I have a triangle here, and I know that, let's see, and I know that this is 12 inches, and this is, let's say, 10 inches. What is the base and what is the height? Give me the dimensions for those. Dimensions for the base and the height are, Josh?
The height is 10 and the base is 12.
Now let me go back and give you what I just said. Anytime you talk about the base and the height, they must form a right angle. Do you see the right angle there, Josh?
No, you draw those dotted lines.
Exactly. You would not be able to find the area of this triangle, okay, until you are given this little dashed line that comes down and they put a nice little corner thing there and they tell you that this thing is maybe 8 inches. Okay, now you can do the area. The area would be 1/2 and you have to multiply the two lines that form the right angle. This and this, the two lines that make that square, are the two that you use for your height and your base. And it doesn't matter which one you take half of first, or even if you do half first. You're going to get half of 96 or 48 inches squared. You must be given this square corner to find the area. And that's true for any formula that has base and height in it. Any formula that has base and height in it, you will have to be given that sort of thinking. Ashley?
Well, like if you get really, really good at math, like really hard math, is there any way to figure it out at all without?
I don't believe so. I don't believe so. Maybe there is. Not that I know. Alright, same thing with a triangle like this. You know, if you know that this is 6 inches, 6 inches, and I don't know, 10 inches, you could not find the area of that triangle. You're not given any two lines that form a right angle. So what they generally do on a triangle like this is they will extend this line out here, and then they'll come straight down with this line here, give you a little corner here, they'll maybe tell you that this is 4 inches, and it's the two that form the right angle, so it has to be this line, which is the 4, and this line. This 6 right here is for this line, I think I should have put it over there probably. 4 times 6, and if I had just a nickel for every time people forgot to cut this in half, I would be incredibly wealthy beyond imagination, because it's true. And I would imagine some of you have forgotten, because we've probably done this before.
Yes.
Triangles are always cut in half. We could get into the long, drawn-out discussion on that, but we won't. And if you're given this triangle here, a lot of times we think that the base of a triangle has to be the thing that it's setting on. Not necessarily the case. Bases are not always what they're setting on. If I was looking for the base and the height here, what two lines would they be? Again, you ask yourself what two lines form the right angle. Sam Poppin?
The base would be 12 inches.
And the height is,
9 inches.
Huh?
9 inches.
oh, that's said 10. You didn't say 10, did you? You said 9, didn't you? Half of 12 is 6, and 6 times 9 is 54. And again, we're looking for area, so you need to make sure you label it as square inches. As that would be. Any